Welcome guys to another exciting episode of Alma's Tutorials. Today we bring to you an interesting topic in business mathematics. But before then, don't forget to like, share, subscribe and click on the post notification bell. If you have any challenges or opinion, kindly write it down in the comment section. You'll be looking at matrices, but under matrices, we have different approaches in solving matrices questions or matrices application questions. We can talk of the inverse, the Cramer's rule, and the others. Today, we are going to look at Cramer's rule. That's using Cramer's rule to solve complex matrices equations or using Cramer's rule to solve matrices application in business. I have this question that I want us to solve. A distribution company supplies goods to two regional markets. The company records that on a particular day, the total revenue from 120 units of product A and 80 units of product B was $2,560. On another day, the total revenue from 90 units of product A and 80 units of product B was $2,080. Assume that the unit price for both products remain constant. Find the per unit cost of each product using the Cramer's rule. Now, after reading the question, we are being restricted to find the unit price for product A and B, assuming that they are all constant using Cramer's rule. Cramer's rule is quite different from inverse or inverse of a matrix, but then Cramer's rule is not that difficult. It's as simple as that. And I think by the end of this video, you'll be able to solve complex matrices equation or any equation at all using Cramer's rule. Let's analyze the equation. It says that the second paragraph, a total revenue of 120 units of product A and 80 of product B was $2,560. Now let A represent product A as the sentence goes and B represent product B. So we have product A. Sorry for the shortcut. We have product A being represented by A. Then we have product B being represented by B. It says that product A, 120 units of product A and 80 of product B. So we have 120 units of product A and 80 units of product B, which gives us a total revenue of $2,560 being our equation 1. Now let's go to the second paragraph. 90 on another day, the total revenue from 90 units of product A and 80 units of product B was $2,080. Now it says that on another day, total revenue from both product A and B was $2,080. We have 90 quantities for product A and 80 quantities for product B, which gives us a total of $2,080. That's our equation 2. Now, as I always say, if you get something like this, you can go by using the normal substitution or elimination method to solve this. But since we are being restricted to use Cramer's rule, which is under matrices, if you use any other method or procedure, you are going to be marked down. So when you have your equation 1 and 2, what you have to do next is that you have to represent this whole equation in a matrix form. So how do we represent this equation in matrix form? We represent this equation in matrix form by taking the both coefficients of all the variables. We can see that the coefficient of A is 120, while the coefficient of B in the second term is 80. Coefficient of A in the second equation is 90, and coefficient of B in the second term of the second equation is 80. So if you are to represent this whole thing in a matrix form, we are going to have 120, 80, 90 and 80 again. Then we multiply it by our variables, which is A and B, which gives us a total market value of $2,560 and $2,080. Now we have represent this equation in a matrix form. Now we are being restricted to use Cramer's rule other than any other method, that's the inverse or the substitution method or elimination method. Now we can name this our matrix as matrix A. Yes, we can name it either matrix A or matrix B. So assuming that this is matrix A. Now the Cramer's rule states that we have to first find the determinants of this matrix, that's the matrix X. So if you have to find the determinant of matrix X, now determinant is by determinant of matrix X equals, you multiply the principal diagonal, which is 120 and 80. After that, you subtract the other diagonal, which is 80. You multiply then subtract from the principal diagonal. So we have to be 120 multiplied by 80 minus 90 multiplied by 80. So this is the principal diagonal and this is the other diagonal. So if you multiply 120 by 80, we are getting 9,600. Then 80 by 90, we are also getting 7,200. The difference now gives us 2,400. Now the determinant for matrix X is 2,400. After finding the determinant of matrix X, the CRAMER rule states that you then replace this side, which is the 2,560 and 2,080, by the first column of matrix X, which you are going to name this. You are going to name it as either X1 or X2. It all depends on you. Since we name this matrix or X, we can decide to name the other one, which is X1 or even S0 or X0. Then the other one X1 or X2. So it all depends on you. After finding your first determinant, that's of the matrix X. So this is the matrix X. Now you want to find the matrix 1, X1. So you are going to matrix X1, determinant of X1. So before you find the determinant of X1, you first have to substitute this value, which is 2,560 and 2,080 at the first column of the matrix X. Now remember, matrix X is 120, 80, 90, and 80. So we are going to substitute this value at the first column of the matrix X to get our matrix X1. So we are going to take this out, 120 and 90, then substitute it by 2,560 and 2,080. So after substituting, we are going to have matrix X1 to be, we have 2,560 and 2,080. Then you maintain the second column, which is 80 and 80. After doing this, you then find the determinant of matrix X1. So determinant of matrix X1 equals, you multiply the principal diagonal. After that, you subtract the other diagonal from the principal diagonal. So principal diagonal gives us 2,560 multiplied by 80 minus 2,080 multiplied by 80. Now, pardon me for the values. The values are too huge, but we have to, go by it that way. So 2,560 times 80 will give us 24,800. So 204,800 minus 2,080 times 80 also give us 166,400. Now, if you take the difference of this, then we are going to have 38,400 as our determinant for matrix X1. So determinant for matrix X1 is 38,400. Now, if we are done with the determinant of X1, you are not done with the whole thing. Remember, we are going after two variables. So we have A and B. So first, after finding the X1, we have to find another X2, which we are going to substitute this one at the second column of matrix X, not matrix X1. We are going to use the matrix X to do our, to do our problem, or we are going to use matrix X in solving in getting our other values. So we are not going to use the matrix X1, but instead we are going to use the matrix X. So we are going to substitute this again at the second column of the matrix X1. So we have matrix X to be 120, 80, 90, and 80. So if you are to substitute this, we are going to maintain the first column, which is matrix X2, which gives us 120 and 80. So if you substitute it, you are going to have 2,560 and 2,080. So this becomes our matrix X2. After that, we find the determinant of matrix X2. Same approach. You multiply your principal diagonal, which is 120,2080 minus 2,560 times 80, which gives us 249,600. 249,600 minus 2,560 times 80, which gives us 230,400. That's 230,400. After that, you strike your difference, which gives us 19,200. 19,200. So our determinant for matrix X2 is 19,200. Now, after finding your two values or the three values, this is the formula for finding for Cramer's rule. So you are going to divide the matrix X1 by the determinant of matrix X. We solved our determinant for matrix X to be 2,400 and the determinant for matrix X1 to be 38,400, while the determinant for matrix X2, which is 19,200. So you are just going to substitute in the values that you had in calculation. So we have our matrix X1, which is 38,400. 38,400. You divide it by your determinant of the matrix X, which is 2,400, comma, you have your matrix X2, which is 19,200. You divide it also by the determinant of matrix X, which is 2,400. Remember, this is the value that you are going to get for A and the value for B. So don't interchange it. So after finding, we are going to divide the determinant of matrix X1 over determinant of the matrix X. So if you divide, you are going to have this one to be 16, then the other one to be 8. So we now conclude that product A is 16 and product 8 is 8. That's $8. So we now conclude that, as the question says, assuming that the unit price for both products remain constant, find the per unit cost for each product using Cramer's rule. So now the unit cost per unit of the products A and B are 16 and 8 respectively. So meaning that product A, that the unit cost of product A is 16, whilst the unit cost of product B is 8. That's all for today's lesson on Amax tutorials. If this video helped you, kindly like, subscribe, and share it to your friends. See you in the next video. Thank you.